Hey there, welcome back for another reading of an abstract time series set, NeurIPS 2022. We'll be reading this one called Generating Multivariate Time Series with Common Source CoordInated GAN, COSCI-GAN by Ali Seyfi et al., coming from the University of British Columbia. They say briefly, this is generating multivariate time series coming from a common source using a novel framework, COSCI-GAN, by focusing on inter-channel/feature relationship preservation. Their abstract says, generating multivariate time series is a promising approach for sharing sensitive data in many medical, financial, and IoT applications. A common type of multivariate time series originates from a single source, such as the biometric measurements from a medical patient. This leads to complex dynamical patterns between individual time series that are hard to learn by typical generation models such as GANs. There is valuable information in those patterns that machine learning models can use to better classify, predict, or perform other downstream tasks. We propose a novel framework that takes time series common origin into account and favors channel feature relationships preservation. The two key points of our method are: 1, the individual time series are generated from a common point in latent space, and 2, a central discriminator favors the preservation of inter-channel feature dynamics. We demonstrate empirically that our method helps preserve channel feature correlations and that our synthetic data performs very well in downstream tasks with medical and financial data. And I'll show you the conclusion. They also provided their code and data in the supplemental that will be linked in the description below. And here are the figures. Looks like they had some impressive results. All right, and then they finish saying, further, it is worth reiterating that synthetic data generation does not guarantee privacy, and similarly, there is no way to know in advance the performance on a downstream task, so both characteristics should be empirically evaluated post-generation. As future work, our method could be extended to more practical use cases where the various channels correspond to different types of time series, for example, heartbeats, temperature, respiration, and wearable measurements, and so on. Yeah, I think I'll skip the rest. And they say the code is provided as modular and parallelized version can be implemented in the future. Oh, and here's their GitHub page down there. Oh, they're referencing a GitHub page down there. Actually, I don't know if I saw a GitHub page. Might not have actually seen one. They have their slides here. I'll show these to you real quick. They're pretty similar to what we already saw. And that's it, guys. So I'll read another one again, and you can follow along in the playlist. So you can just keep these going and listen to all the different abstracts from NeurIPS and ICML and ICLR. All right, guys, you take care. Bye-bye.